important that you feedback on the quizzes. Okay, so we were talking about integers and number patterns in this quiz. And the first question that I had asked you was to define what an integer is. So hopefully you said a positive and negative number, including zeros. The answer was A. In the second question, a negative multiplied by a negative is a positive. So hopefully you said that for question B. In question 3, when adding a negative, we move to the move right to the left on the number line. Hopefully you said that as well. Question number 4, when we subtract positive numbers, it is the same as subtracting. Apalele, you got a question? What would you like to ask?
Oh, sorry, ma'am. I touched the hand on mistake.
Oh, okay, that's fine. No problem. All right, where were we? Question number 4. So when we subtract positive numbers, it is the same as subtracting. A positive number divided by a negative number is a negative. Hopefully you said that as well. And where that 5/11 came from, but anyway. All right, then we moved on to number patterns, and we said that if we substitute n equals 2 into tn equals 3n minus 4, we would replace n with 2. So 3 times 2 is 6 minus 4 means tn would be equal to 2. So hopefully you got that. The 7th question, if tn equals 3n minus 4 and tn is negative 1, it means that n is equal to. So you have to work backwards to calculate the value of n. I am going to do this one with you because I think it is just a little bit more difficult than what the others were. So what you were supposed to do here, grade 7s, is make 3n minus 4 equal to negative 1. And then we would have added 4 to both sides. So 3n would have been equal to 3, which means that n was equal to 1 in this case. All right, then it started to get quite a lot more difficult after that. Oh, hang on one second. Let's reply to somebody here. There we go. All right, so in question number 8, I had said that 1 goes in and negative 6 comes out, and 2 goes in and negative 9 comes out, and 3 goes in and negative 12 comes out. And I had asked you what the rule for the pattern was going to be. So if you recall, what we had to do was work out the constant difference between our terms. So minus 9 minus negative 6 would have given us negative 3, and minus 12 minus negative 9 would have also given us negative 3. That becomes our multiplier. So now we're going to take negative 3 and we're going to multiply it by our first input, which is negative 3, but that's not what we get out. We get out negative 6. So if we're sitting at negative 3 on the number line, we have to take away another 3 if we want to get to negative 6. And then we can continue to test our pattern to see whether it works. So if I take minus 3 and I multiply it by 2, I would end up with negative 6. If I take negative 6 and I subtract 3, then I would end up with negative 9. And similarly, if I took negative 3 and I multiplied it by 3, my next input, I would get negative 9. And if I take negative 9 and take away 3, I would end up with negative 12. So that's why you were supposed to say that the nth term for this particular pattern was the rule Tn equals 3n minus 3. Hopefully that was fine for all of you. Okay, then write down the next 3 terms in the pattern below. So the first number was 2,2. The next number was 2,5, then 2,8. So hopefully you realized they were going up in increments of 0,3, which means that the next, oh, hang on a second. I think I made a mistake there. Sorry. Kat, am I right? I have made a mistake, isn't it? Because if you were going up in increments of 3, then this should be 3,1, shouldn't it?
I am very lost because I was renaming someone. Let me see.
Oh, okay. All right. Oopsie. I think I made a mistake there, but anyway. we were going up because cat, if a pattern goes 2,2, then 2,5, then 2,8, means you're going up in 0,3, right?
Then it's
so then it should be 3,1, then 3,3,
4, isn't it?
Of course, 3,4, and then
3,7.
3,7. Oopsie.
Yes.
My apologies, grade 7s. I didn't get that one correct. Okay, the next one I know is definitely fine. Write down the next 3 terms in the pattern. So this was, again, was a little bit more difficult. What I wanted you to realize is that when you go from one term to the next, you add 0. Then you add 1. Then you add 2. Then you add 3. So you're supposed to add 4, and then 5, and then 6. And that's why you would have ended up with 11, 16, and 22. Okay, are there any questions? All right, let's just see if there's somebody else to rename. Oh no, that's fine. Okay, no questions? All right, then in that case, let's move on. All right, so what I wanted to focus on today was, or is, the easiest thing that you can do with fractions, which is to multiply them. And as far as multiplying fractions is concerned, I found this diagram when I was preparing my lesson today, and I think that that just really kind of explains it so very, very well. So if we have a look on the left-hand side here, if we want to multiply 2 fractions together, the 2 fractions in this picture are 2/7 times 3/5. Can you see how when we multiply them together, we basically get an overlap of the 2, all right, which is the product of the 2. So what's happened here is that we have multiplied our numerators together and we have multiplied our denominators together. The numerator is the number in the where? Grade 7s, the numerator is the number at the hands up. Where does the numerator go? Indinako, where does the numerator go?
At the top.
At the top. Lovely. Well done. Thank you. And Rolivua, where does the denominator go?
At the bottom.
At the bottom. Lovely. Well done. Okay, so multiplying fractions really is supposed to be quite straightforward. We multiply the numerators, we multiply the denominators, and then we reduce the fraction if necessary. Okay, so in the case of the one on the right-hand side, we would say 2 times 3 is 6, over 5 times 4 is 20, and then if it's possible to reduce that fraction, we would then do so afterwards by dividing both the numerator and the denominator by the same amount. So we can't reduce the fraction if we divide the top and the bottom by something that's different. It has to be the same. Okay, so in this case here, to go from 6/20 to 3/10, we've divided both the top and the bottom by 2. All right, and then 3/10, we would say that that is in simplest form. That means that there are no more common factors left over. All right, so it's not possible to divide the top or the bottom by anything else. All right, so just a couple of examples that I wanted to do with you before you guys go ahead and go and try these. The first one is question number 9. And if we have a look at this question, we can see that there's no simplification that can be done first. So as far as simplifying is concerned, we can only divide something at the top with something at the bottom. So there's no common factors between 20 and 1 and 3 and 9. Yes, Indinako, I see you've got a hand up. You want to ask a question, Indinako? No? Okay, and I'll continue. If you do have something that you wanted to ask me, then you're very welcome to. Oh, okay, no problem. Pop it in the chat or whatever. Okay, so here we cannot simplify anything. We cannot divide anything at the top and anything at the bottom with a common factor. So we have to say numerator times numerator. So 1 times 20 leaves us with 20 over 3 times 9, denominator times denominator, leaves us with 27. All right, and because there was nothing for us to cancel in the beginning, there's not going to be anything for us to cancel now here at the end. Okay, so now if we have a look at number 14, it's a little bit different. We can cancel down here. I mean, we don't have to if we don't want to, but if you are supposed to be doing this without the use of a calculator, which is what you should be doing in grade 7 and grade 8, then we would want to cancel down first, just to make it easier for us to multiply together. All right, so if we have a look, we can see that there are two numbers that share a common factor. What are those numbers in this case? Hands up. What are the two numbers that share a common factor in question number 14? What can I divide at the top and the bottom? I can divide both of them by the same thing. Does anybody know? Sure, Relivua, go for it.
I don't know, but at the bottom is a 2.
Okay, so you have to divide the top and the bottom by the same. You can't just divide by the same thing on the bottom without doing it at the top. Otherwise, your ratio, or the way that your numerator is related to your denominator, you're going to change that relationship. Okay, so you've got to look at the top and at the bottom. Do you want to try again, Relivua?
I don't know.
That's okay. That's okay. That's okay. I'm glad you don't know, because that's why we're doing this. Okay. So what I wanted you to have a look at here, what I'm trying to get you to see, is this number 15 at the top and that number 6 at the bottom. They share a common factor. So now that I've pointed the numbers out, do you know what number goes into 6 that also goes into 15, grade 7s? Lesedi?
3.
There we go. Lovely, 3, absolutely. So what we can do, Lesedi, is we can say 6 divided by 3 is 2. And then I can do the same thing in the numerator. I can take 15 and divide it by 3, and I'm going to end up with 5. Okay, so either you can go from numerator to the denominator in the fraction that's next to it, or you can work with the numerator and the denominator that's below it as well. It just depends. Okay, but it's got to be something at the top and something at the bottom. Okay, if they can both be divided by the same number, it means we can simplify first. Now we have to do the same thing. Multiply numerator with numerator and denominator with denominator. So we would say 5 times 7 is 35, over 8 times 2 is 16. Now, when you are in high school, you are allowed to leave numbers as improper fractions, provided there are no more common factors. So I could leave 35 over 16, but if I had something like 18 over 12, I couldn't leave that, all right? So as long as there are no more common factors, then you're allowed to leave it. If there are still common factors, then you've got to simplify it. So in this case over here, what could I divide 18 by that I can also divide 12 by? What number goes into 18 and into 12? Indinako?
6.
Oh, lovely. Okay, so you would say that 6 goes into 18 3 times, and 6 goes into 12 2 times. So in its simplest form, it would be 3 over 2. Can you see how it's still improper? It's just in its most simplified form now. Okay, so as long as it's improper is fine. It just has to be in its simplest form. If in primary school they want you to write numbers as mixed numbers, then what you would have to do is work out how many times the denominator goes into the numerator using your times tables. So you would say 16 times 1 is 16, 16 times 2 is 32. So the most number of whole times that 16 goes into 35 would be 2 times, with a remainder of 1, 2, 3 to get to 35. So 3 over 16. You do not have to do this in high school, but if they do want you to do it in primary school, that is the way that you would do it. Okay, everybody happy? Are there any questions? No? Okay, all right. So now you guys are going to try these ones. All right, so number 1, number 6, and number 11. Once you've done all 3, then you can put your hand up to give an answer. Goodness me, Oliver, you got your hand up already. Are you finished?
Yes, I'm finished.
Oh, wow. It was really fast. Sure. Hey, Kat. She's Speedy Gonzalez, isn't she?
That was pretty fast. In my mind, I'm like, does she have a question? Or Anati
Yeah.
looks like she's done also.
Oh,
And
wow.
Indinako. Oh.
Nice.
There's a lot of hands going up.
Okay, there are a lot of hands going up. And
All right,
Patson and
smarties.
Mandisa.
Mandisa, what's your name? I'm pretty sure it's not Mandisa.
Yeah, I don't remember anybody called Mandisa. Do you?
No.
No. All right, Rolivua, since your hand was up first, you do the first one. What did you get as an answer?
I got 5 over 8.
Lovely. You are so good. Well done. Okay, so you multiplied numerator with numerator and denominator with denominator, and there was nothing that you could simplify. Good job. Well done. Anati, go for it.
I've got 5 over 12.
5 over 12. Lovely. Now, also, again, there's nothing there that can be simplified. Perfect. Good job. Indinako, the next one's all yours.
I got 110 over 18.
110 over 18. All right. Over 18. I agree with you. But if I said to you that it had to be in simplest form and you left your answer as it is now, would you get full marks?
No.
Okay, so what can you divide numerator and denominator by?
2.
So 2 goes in here.
5. Wait,
5.
no. Mama Bowenzani.
Oh, I am to walk on.
You're on the right track, Indinako. So 2 goes in there
55.
how many times? Yes, good. Well done. 55 times. And 2 goes in here?
9.
Lovely. All right, very nice. Okay, so your final answer, 55 over 9. All right, 100%. Well done. Patson, 65 over 9. No, can't be. If it was 130 over 18, then maybe Patson, but 110 definitely not. Okay. All right, that's fine, Patson. I'm glad you were still trying. Well done. Lovely work. Okay, now let's talk about multiplying whole numbers and fractions together. All right, so in the case of question A, I want to see if you guys know, what would we do? So you can put hands up if you think you know. Okay, Anati, how would you multiply these two numbers together? What would you do?
I would have to make the whole number into a fraction.
Okay, so how would you make it into a fraction? How would you write it?
Would it be 2 over 2?
2 over 2? Which one for 9?
Yes.
Oh, so are you saying that the denominators have to be the same?
Yes. No, I mean like
Okay, so let me ask you a question, Anati. When I say the number 9, 9 is a fraction. It means 9 over?
9.
9 over 1. Okay, so 9 over 9 is 1. Anything divided by itself is 1. So if a number has the value of 9, then it has to be 9 over 1 in order to have a value of 9. Does that make sense to you?
Yes.
All right. So any number that's been given, any real number, it can always be written over 1. So 9 times 3 over 2 specifically means 9 over 1 times 3 over 2. That's what it means. Are there any common factors that you could simplify, Anati?
Yes.
Okay, what could you simplify?
9 and 3.
But they're both
9 and 3.
But they're both in the numerator, so you can't simplify numerator and numerator. It has to be the numerator of one and the denominator of the other. So are there really are there really any common factors?
No.
No, nothing. Okay, so what do you have to do now?
9 times 3 equals
Beautiful.
27.
Yes,
1
over.
times 2 equals 2.
Lovely. There you go. Well done. Okay, good work. All right, Lesedi, you up next. Do the next one for us, please, Lesedi. Question B.
So, ma'am, first you'll make 12 over 1.
Mm-hmm.
And then you go 12 over 1 times 8 over 3. So
Sure.
12. Yes, and then 12 times 8, which is 96.
It is.
And then 1 times 3, which is 3.
Lovely.
And then you can simplify it to
You're right. Keep going. You can simplify it to
32 over 1.
32 over 1. All right, which you would just write as 32. Well done, Lesedi. Now, if I said to you that you had to simplify first, what could you have done differently here? When you said 12 over 1 times 8 over 3, what could you do differently there, Lesedi? Any idea?
I don't know, ma'am.
Okay, all right. So, Lesedi, can you see that you have got 3 at the bottom of this fraction and you've got 12 at the top of that one?
Yes, ma'am.
3 goes into 12, doesn't it? How many times?
Goes into it 4 times.
Absolutely. So what you could do is you could say 3 goes into itself once and it goes in here 4 times. And 4 times 8 over 1 times 1 would still give you 32 as an answer. Does that make sense?
Yes, ma'am.
Okay. All right. Well done, Lesedi. That's really good. Let's see who's got a hand up now. Okay. Retu, all yours. Do question C, please, Retu. Question C, please, Retu.
3.
Say again, Rachel, I didn't hear you.
I'm still calculating.
Oh, okay. So at the top, Rachel, you've got 15 times 10. What would that leave you with?
15. 1.
You got an answer, Rachel? Okay, I'm going to go to Motibang. Please, Motibang, what would you do here? For question C, Motibang.
Sorry, ma'am.
It's okay. What would you do here, Motibang?
I'll say 15 over 1 times 10 over 7.
That's lovely. And if you said 15 over 1 times 10 over 7, what would you end up with?
I think it would have been 150 over 7.
Hey, you are too clever, Motibang. Well done. That's very nice. And if I
Thank you,
said to you that you had to write that as a mixed number, what would you do now?
I think I should cross it.
You think you should cross it?
Yeah, is it like that, ma'am?
It's like this. So in other words, what you need to do is you need to figure out how many times 7 goes into 150. So you would say, does 7 go into 1? No. Does 7 go into 15? Yes. How many times does 7 go into 15?
Twice.
Twice, exactly. All right. And 2 times 7 is going to leave us with 14. All right. So then we would subtract and we would bring down. Obviously, we're going to end up with a decimal here. All right. How many times does 7 go into 10?
7 go into 10. It's once.
It's once, absolutely. And what would be left over?
Is it 14 over 7? So
That's okay.
sorry, ma'am, I couldn't see the numbers that you are writing.
Oh, okay. All right. So if I said 21 times 7, I would end up with 147. Does that make sense to you?
Yeah.
All right. So that means that 7 would go into 150 21 times with a remainder of 3 over 7.
Oh.
Does that make sense now?
Yes, ma'am, it makes more
Okay.
sense.
All right, that's good. Now, that's only if you had to write it as a mixed number. If you're in high school, then they don't expect you to write it as a mixed number, but in primary school, they might still expect you to do that. So that's how you would do it. Okay.
Yes, ma'am.
All right, good job. Well done. Very nice. All right, let's see who's next. Oh, Tatelo. Nice to hear from you, Tatelo. Please, will you tell us how to do question D?
Hi, ma'am.
Hello, how are you?
Hi, ma'am.
Hi. How would you do question D?
How are you, ma'am?
I'm fine, and you?
Yes, ma'am.
That's good.
Good, ma'am. So, ma'am, what I did was the whole number 2, I did it 2 over 1
Mm-hmm.
times 20 over 3
Yeah.
equals 40 over 3. And then I made sure that I found out how much does 3 get into 40. But
Mm-hmm.
it only goes 12 times, so there's only a remainder of 4, so it can be.
Okay, but now hang on a second, okay? Now, what you've told me here, Tatelo, is lovely. It's really, really lovely. But in fact, 3 can go into 40 more times than just 12. Because if you take 12 Well, I'll tell you what, let's do this. Let's take 40 and divide it by 3. We would say that 3 goes into 4 once with a remainder of 1. 3 goes into 10 3 times with a remainder of 1. Okay, so in other words, it would go in 13 times because 13 times 3 is going to leave us with 39. 3 times 3 is 9 and 3 times 1 is 3. So that would be 13 and 1 over 3 times that it would go in. Okay, but if you've got 40 over 3, I mean, as I say, I don't know in primary school, but in high school, if you left your answer as 40 over 3, they would give you 4 marks. Okay, let's see who's next. Indanako, go for it. Question E is all yours, Indanako. What would you do here?
I said 20 over 1 times 12 over 27, which is 240 over 7.
Absolutely. And there's no ways that you could simplify that.
No.
No, okay, because there's nothing that goes into 7 that goes into 12 or 20. All right, and if you had to write that as a mixed number, how would you do it?
Say 240 divided by 7.
Mm-hmm.
And it would give me 7 doesn't go into 2.
Yeah.
7 goes into 24 3 times.
I agree.
With the remainder of, then you say 24 minus 21, which is 3, bring down the 0, and then 7 goes into 34 times.
It does. Okay, and that would leave us with?
28.
28. Okay, and then again, we would have to bring down a remainder.
0.
Absolutely. So once we had got to the point where we had said to ourselves, okay, so 34 times 7, what would we end up with?
4 times 7 is 28. Put it 2.
Yes.
3 times 7 is 21 plus 2 is 23.
Okay, there we go. So it would go in 7 times with a remainder of 2 over 7. Is that right?
Yes.
There we go. Lovely. Good job. Well done. Nice work. Okay, now I think it was Devin who had his hand up next. Devin, how would you do question F, Devin? Are you there, Devin?
His camera is off also.
Oh, okay. All right. Because I know he had his hand up.
Yeah.
Let's see if there's... Okay, that's fine. Let's see if there's somebody else who wants to go in Devin's place. Oh, Mbali. Hello, Mbali.
Hello,
How are you?
fine, and you?
I'm fine, thank you. You going to do this one for us, Mbali?
Yes.
Awesome, thank you.
So it is 120 over 1 times 5 over 18
Lovely.
equals 600 over 18.
I agree, absolutely. Would you leave your answer like that, Mbali?
No.
No. Okay, so what would you do next?
I would simplify it.
Okay, what would you divide the top and the bottom by?
18. No.
Okay,
Yes, 18.
Okay, but does 18 go into 600 exactly? Or would there be a remainder?
There will be a remainder.
There would be a remainder. I agree with you. Okay, but you are right. You are looking at 18 into 600. Okay, so if we did that and we said 18 doesn't go into 6, but 18 goes into 60, how many times would 18 go into 60?
3 times.
It would go in 3 times, quite right. Okay, and 3 times 18 would leave us with?
6.
3 times 18?
3 times 18 is 54.
Good. Okay, so it would go in 3 times. That would leave us with 54. That would be a remainder of 6. And then we'd have the same problem where 18 needed to go into 60 again. So how many times would that be?
Sorry, can you repeat?
Sure. Okay, so now we've said that 18 goes into 60 3 times. 3 times 18 is 54. The difference is 6. We brought down a 0. So now we need to say 18 into 60. How many times does it go? Same story again, isn't it?
Yes, 3 times.
It would go in 3 times, absolutely. And that would give us another 54, which would give us another 6. All right, so we know that it goes in 33 whole times. And that's because 33 times 18 is going to give us how much? Ooh, that can't be right. What did I just do? Okay, so 33 times 18 is going to leave us with 594. Are you also getting that?
Yes.
Yes. Okay, so that means that it would go in 33 times with a remainder of 6 over 18, which would be 1 over 3. All good?
Yes.
Okay, all right, there we go. Well done, good job. Okay, so now we're going to move on to something that is a little bit more difficult. What do we do when we multiply mixed numbers together, grade 7s? How do we multiply mixed numbers? This first one isn't a very nice one. I don't want to start there. We're going to start with the second one. Let's see who's got a hand up. Mandisa, so nice to hear from you. Mandisa, how would you multiply together 2 mixed numbers? What would you do?
Ma'am, I'd say 4 times 1. Plus 1. And then I'll say 3 times 2 plus 1.
So am I right when I write 5 over 4?
Beg your pardon, ma'am?
Am I correct in writing 5 over 4 for your first improper fraction?
Yes, ma'am.
Good stuff. And then you said you would say 3 times 2 plus 1, which would leave you with?
6 over 3.
7 over 3?
Yes, ma'am.
Okay. And then from there, what would you do?
Ma'am, I'll say 5 times 7.
Yes, and that would give you?
35 over 3.
Okay, that's wonderful. Well done, Mandisa. Good job. It's really nice.
Isn't that 12?
Oh, it is 12. So here I'm like, well done, Mandisa. Absolutely.
4 times 3.
No, 4 times, yeah, quite right. 4 times 3 is 12. There we go. Lovely. I think Mandisa was also looking at 1 as well. I think it's just the way I had written it. Okay, good job, Mandisa. Well done. Thank you, Kat, for always being on the ball like you always are. Mujalipa, so nice to hear from you. Will you do number 3 for us?
Yes, ma'am. Hello, ma'am. So, ma'am, it's going to be 7 times 4 plus 3, and then it's going to be 31 over 7, and then it's going to be 5 times 3 plus 3, which is 18 over 5,
Oh,
and then
that is
we
a
are going to find, we're going to do, we are going to find the same, I forgot what it's called. I forgot what it's called, but I know I'm not supposed to do, just forgot what it's called.
Okay, so when you multiply fractions, you have to multiply numerator with numerator and denominator with denominator. So you have to say 31 times 18. What would that leave you with?
Uh,
Bit of a horrible one to have to multiply.
558.
It is indeed 558, absolutely. So we'd have 558 in the numerator. What would we have in the denominator?
35.
35. Quite right. Well done. I think we'll leave our answer just like that. Good job. Well done. All right. Let's see who's got their hand up next. Fundiswa. Fundiswa, please will you do question 4 for us?
Yes, ma'am.
Good.
Firstly, I would say 5 multiplied by 3 plus 1.
Quite right. And what would that give you?
Multiplied by 1 multiplied by 4.
Just as you had said, so you'd have to say 3 times 5 plus 1. So 3 times 5 is?
3 times 5 is 15.
Good. 15 plus 1 is?
16.
Good. Well done.
Over
so
5.
16 over? Not over 5, Fundiswa. 16 over?
Over 3.
That's it. 16 over 3. Good. Do the next one. Make it an improper fraction.
Multiplied by 1 multiplied by 4 plus 3.
Good. That would leave you with?
Equals to 7
Over?
Equals to 7 over 4.
Lovely. Well done. And now what would you do?
And multiply by the numerator and the denominator by the denominator.
That's right, Fundiswa. But you know what? There's something that you can do with this question that will make things easier for you. Instead of having to say 16 times 7, you can simplify first. What can you simplify? What am I trying to get at?
Simplify 16 and 4.
Oh, 16 and 4. Good. So you would say 4 divided by 4 is 1. 16 divided by 4 is 4.
4.
Absolutely. And now what are you going to do, Fundiswa?
4 multiplied by 7.
Lovely. And 4 times 7 is?
4 multiplied by 7. 28.
Good. Lovely. Well done, Fundiswa. And 3 times 1 is?
It's 3. 1.
Lovely. 3. Perfect. Well done. That was lovely. Very, very nice. Well done, Fundiswa. Thank you so much. Okay, now let's see who's next.
Thank you.
Well done, Fundiswa. Oh, it's so nice to hear from you. Oh, would you number 5 for us, please?
Yes. Are we like in number 5?
Number 5, lucky number 5.
Okay. So you 2 times 5 plus 3. And then 2 times 7 plus 1.
Absolutely. So 5 times 2 plus 3, what are you going to put that over?
5.
That's it. So we would have 13 over 5, right?
Yes.
Okay, and then you said 7 times 2 plus 1 gives you how much?
15.
Lovely. And what would you put that over?
7.
Uh-huh. Okay. And now you're going to multiply these numbers together. But again, try and challenge yourself to do it by simplifying first. What can you do here?
So you can look at 5 and 15.
Lovely, Ola. What are you going to write?
So 5 can go into itself once and 5 can go into 15 3 times.
Beautiful. Well done, Olga. Finish it off now. That's great.
13 times 3, 39.
Beautiful. Over?
7.
That's it. You did it. Well done, Olga. That's really lovely. Good job.
Did you need to simplify it?
Well, it is in its most simplified form, but what you can do if you are required to is write it as a mixed number. That's not simplifying though. Simplifying means when you are dividing the top and the bottom by the same factor, that's simplifying. But when you write it as a mixed number from an improper fraction, that's not actually regarded as simplification. Because it's still in its simplest form. But I mean, I'm just being very technical now. If you want to, and you are, I mean, I don't know, some schools, I think at primary school, they do want you to write it as a mixed number. At high school, they don't make you do that. But if they did, if they said to you, okay, you've got to write this as a mixed number, what would you do now, Olga?
If you had to write this as a mixed number,
what would you do?
So you must think to yourself and say, how many times can 7 go into 39?
Exactly. And how many times would 7 go into 39? How many whole times?
7, 20, 28. 5 times.
I agree. And what would be your remainder?
5.
Sure?
Oh, 4.
That's it. 4. Over?
7.
That's it. Okay, good job. Well done. I'm so impressed.
Thank you.
That was lovely. That was really lovely. Well done. Good job. Okay, let's see. Oh, Solam. It's so good to hear you. Solam, go for it. Will you do number 6 for us, please? Go for it, Solam.
Sorry, I couldn't unmute.
That's okay.
So I did 4 times 4, 16 plus 3.
Yeah.
19.
Over?
Over 4.
Lovely.
Then I did 1 times 6 plus 1, 7 over 6.
Okay. Do you have any common factors that you can simplify?
No.
No. Okay, so this is a bit of a nasty one, Solam. All right, so now you have to say numerator times numerator over denominator times denominator. Okay,
Yes.
so how are you going to work out 19 times 7?
I got 133.
133. I agree.
And then I got 24. Oh, sorry, yeah.
Yeah, no, 24 is the right answer. Very good. Well done.
Thank you.
Okay, good job. That's really lovely. Well done, grade 7s. You are doing amazingly. I'm so impressed. Really, really good. Okay, so we've only got 10 minutes left. Our time always goes by so fast, doesn't it? Okay, so now we're still talking about multiplying fractions, but now I've involved exponents because this is something that we were talking about earlier in the term. All right, so if I was to give you 3 over 5 and then I squared it, what am I asking you to do? All right, so now I'm going to see who's, let's see whose hands are up. I love hearing from people who don't normally put their hands up, so that's really cool. Okay, Mojulifa, go for it. What does it mean if I ask you to square 3 over 5? What am I asking you to do?
I think Majalifa had a question because he asked me in the chat.
Oh, did he? Okay.
Yeah.
All right. All right. Patson. Does Patson have a question or do you know the answer, Patson?
No, I think he.
Yes, ma'am. It's the same fraction, ma'am. You multiplied by itself twice.
You see, you're too clever, Patson. You don't need to come for lessons anymore. Well done, Patson. That's quite right. So you've got 3/5 multiplied by?
3/5.
3/5. And your answer would be?
It would be 9/25.
Lovely. Okay, so we square the top and we square the bottom. Okay, when we are squaring fractions, we square the numerator and we square the denominator. Okay, let's finish this off. Let's see. Okay, Indinako, you are next. Will you please do D for us, Indinako?
5/9 times 5/9 is 25/81.
Well done, Indinako. That's lovely. Good job. Well done. Very nice. Takalani, go for it. You do question E for us, Takalani.
Yes, ma'am. So, ma'am, I said 3/5 times 3/5 times 3/5, which gives us 27/125.
Lovely, Takalani. That's beautiful. Well done. Very good. Nice, nice, nice. Okay, Solam. Well done. Solam, do the next one, please.
I did 1/4 times 1/4, which is 1/16.
It certainly is. 1/4 times 1/4 is 1/16. Good, Solam. Lovely. Nice. Who's next? Ntakelo. Ntakelo, please do G for us. Okay, Ntakelo, this is not distribution. Go for it. Ntakelo, what should we write for G?
1/4 times 1/4 times 1/4.
Indeed, well done. And what would we end up with as our answer in the numerator, Ntakelo? You'd end
It's
up with
1/12.
1/12. Are you sure? 4 times 4 times 4. Are you sure that's 12?
It's 64.
It certainly is 64. Well done, Ntakelo. That's very good. Okay, so often it's easy for us to get confused about what an exponent means. But when they tell us, for example, if we've got 2 to the power of 4, it's an instruction on how many times to multiply 2 with itself. So it means 2 times 2 times 2 times 2. It does not mean 2 times 4. Okay, let's see who else has got a hand up. Inati Ndlovu. I hope I said that correctly. Inati Ndlovu? Inati Ndlovu?
Yes, ma'am.
Oh, so nice to hear from you. Thank you so much for putting your hand up.
Yes, ma'am.
Go for it. How would you do this question?
4/7 times 4/7.
Lovely. And you would end up with what?
12 over...
Are you sure it's 12, Nati?
16.
Good. Over?
7, 14, 28, 35, 42, 49.
That's it. Well done. That was really, really good. Excellent work. Well done. It was so nice that there was a whole lot of you that put your hands up that don't normally put your hands up. Okay,
Yeah.
Lisa, isn't it?
That was great.
It was really, really awesome. Okay, now, did the rest of you want to ask a question or did you just put your hands up because you wanted to do an answer? Kat, can you help me with that?
Let me, okay. Let's do this.
Okay.
Okay, guys.
Oh,
Did you all
Patson
want
says he wanted to answer. All right, Patson.
I think
Okay,
most of
Panola
them
also
did,
to
yeah.
answer. Okay. I just want to address something that I was asked in the chat, and I just want to clear that up as well, right? If, for example, okay, and this can apply to fractions and also not, but if I say something like this, if I say 2 times 2 times 3, is this distribution? I'm asking grade 7s. If I say 2 times 2 times 3, I agree, Cynthia. Well done, everybody. Is that distribution? Is that the distributive law? Yeah. I'm glad I asked then, Patson. Patson says he doesn't know. Okay, because somebody asked me if we were doing distribution. Okay, now distribution is very important in grade 8. Well, mind you, all the way through to matric, all right? Distribution happens when you are multiplying across addition. So this is not distribution. So the answer here is no, this is not distribution, because what this means is 2 times 6, the answer would be 12. So distribution is when you are adding 2 things together. So let's say I add together 2 and 3. But then I want to multiply the sum of 2 and 3 by 3. When I say this means 3 times 2 plus 3 times 3, then I am distributing. I'm distributing the 3 over the sum of 2 and 3 together. So that would be 6 plus 9, and that would leave me with an answer of 15. Okay. And that's because if I add 2 and 3 together, I would get 5, and 3 times 5 would give me 15. Okay, so that's just to answer that question. Okay, well, we've ended off with 1 minute to go. That means you guys have got time to do the poll, and then we can say goodbye. Thank you, cats.